Hi everybody, today I have a nice geometry visualizing question for you from PUMaC. So it is Princeton University Mathematical Competition. So from 2011 PUMaC we have a semicircle and this semicircle get folded from a point, and this is the figure which we get after folding the semicircle, and these dashed lines form the pre-image of semicircle. And let AD be the diameter of this semicircle, and where the folded semicircle get intersect with the diameter, let these points be B and C and this chord like figure be M and N. If AB is to BC is to CD is equals to 2 is to 5 is to 3 and the radius of the semicircle is 5, then find the length of MN which we get after folding the semicircle. So please give your trial to this question and keep watching for the solution. So for the solution, we need to prove a result which I already proved in my many videos, which is if we have a bigger circle and then another circle which is intersect at any 2 points of first circle, let A be are these points and let O be the center of first circle and O dash be the center of another circle. Now join these AB and this is a common chord, and now join the centers of both circles and draw the radius to the points A and B from first circle. Let radius be R, and from another smaller circle drop the radius to point AB and let the radius be small r, and let the point where common chord and line joining the centers intersect be C. So after this all congruency we get angle AO dash O is equals to angle OO dash B by CPCT or corresponding parts of congruent triangles. Similarly, we have this angle which is BOO dash is equals to angle AOO dash again by corresponding parts of congruent triangles. Now doing congruence in triangle AOC and triangle BOC, we have that this complete angle is a right angle. And one more thing that we get is the common chord is bisect by line joining the center of both circles, and this is by corresponding parts of congruent triangles. And this is the result that we need to find our final answer. Now here is our figure. For finding our answer easily, we can extend the semicircles to form a pure circle. So here is our first circle, and here is another intersecting circle, and this is common chord and diameter is A and D and intersected points are B and C and common chord is M and N. Now we'll just rotate this figure horizontally to make it more easier to understandable. Now let the center of first circle be O and center of another circle be O dash. Now join these centers and now join the common chord, and we know that it is perpendicular, and it is a fact that the radius of imaginary circle drawn from extending the arc of the semicircle has exactly the same radius of original semicircle. So from this we know that this line is equals to this line after doing some congruency, and the line O dash n has the radius equals to 5. So by using Pythagoras theorem we can easily find m and if we have the length of O dash O. So now our search is going to find the length of O dash. So let's get started. Now join O dash B and O dash C, and we know that it is the radius with perspective to the O dash centered circle, and we have given that this information. So from this we find that AB is equals to 2, BC is equals to 5 and CD is equals to 3. Now we know that the radius of another circle is 5, so these lines are 5, and OC plus OB is equals to 5. After subtracting CD and AB from AD. Now triangle BCO dash is an equilateral triangle, so this angle is equals to of 60 degrees. Now finally joining the centers of both circles and now using cosine law, and BO is equals to AD minus AB plus OD, which is equals to 3. So BO is equals to 3, and now finally using cosine law in this triangle BOO dash, so we have cos of 60 degrees equals to BO square plus BO dash square minus OO dash square by 2 times BO times BO dash. So after putting the values we have get this, so this, and now finally we have O dash square is equals to 19. Now finally joining the common chord, and we know that it is perpendicular and these lines are equal from our this result, and now joining the radius, and now finally using Pythagoras theorem in this triangle. So by Pythagoras theorem, and O dash square is equals to NM by 2 square plus OO dash by 2 whole square. So we have this, and putting the value of OO dash square with this, so we have this. So MN is equals to 9, and that is our correct answer. And it is really a tricky geometry problem. I know the solution is very short, but it's really tricky.